Hello, and welcome to the Workflow Show, where you get some workflow therapy whilst listening to discussions on development, deployment, and maintenance of secure media asset management solutions. I'm Jason Whetstone, Senior Workflow Engineer and Developer at Chesapeake Systems.
And I'm Ben Kilberg, Senior Solutions Architect.
Today, you'll be hearing our interview with Eric Bassier, Senior Director, Product and Technical Marketing at Quantum. Eric will be helping us guide you through some of the storage and networking technologies behind StorNext, the modern file system offered by Quantum. We'll be discussing storage technologies like NVMe, its performance benefits and advantages, and how well it pairs with networking technologies like RDMA. We'll talk about hybrid cloud and maybe even file systems in the cloud. And we'll cover some use cases for block-level storage versus object storage. And finally, Eric will give us some vision into the future of StorNext by talking about the roadmap for StorNext 7 and beyond. Before we get to that, though, we have a few quick things to ask of our listeners. First, you can reach out to us directly with questions and thoughts on anything at workflowshow@chesa.com. We're also trying to get to know you better, so let us know how you found out about the Workflow Show. You can reach out over email or at CHESAPro on Twitter. And if you enjoy listening to the Workflow Show, then listen up. We've leveled up our content production schedule, which means more episodes, more guests, and more workflow therapy. So please subscribe to the podcast so you know when the next game is on. Before we start our discussion with Eric today, I wanted to call out some previous episodes that cover some of the same information that we are going to talk about today, but maybe in a little bit more depth. I wouldn't call them prerequisites for listening to this episode, but they do give you some more in-depth information on some of the subject matter. So the first one would be number 27, NAS versus SAN Made Clear. It's actually one of our most popular episodes where we sort of compare and contrast the difference between a SAN and a NAS. The next one would be number 33, File Systems and Beyond. Our guest there was Brian Suma, our Senior Systems Engineer. We talked to him about what a file system is and how they interact with systems, workstations, servers, etc. And last but not least would be the episodes from part 2 of our 5-part Media and Entertainment Basics series. So those episode numbers would be 49 and 50. All right, and without further ado, let's get into our topic. I'd like to introduce our guest, Eric Bassier, Senior Director, Product and Technical Marketing at Quantum. Welcome, Eric.
Hi, Jason and Ben. Thank you guys for having me.
Absolutely.
Thanks for joining us.
Yeah. So we talked in our Media and Entertainment Basics series just a few episodes ago about some different storage technologies. And what I'd like to do is just give a brief recap. I want to talk about the newest, latest, and greatest one, the one that everybody's kind of talking about these days, which is NVMe. So, Eric, why don't you give us just a high-level overview of what NVMe is and why it's so cool?
Yeah, for sure. NVMe stands for a non-volatile memory express. It's actually a new protocol for reading and writing data to flash. And, you know, in this industry, we're seeing a lot of our customers deploy this really over the last year and a half for kind of that tier 1, production and post-production. We can get more into the technology as we go, but it's orders of magnitude faster than traditional hard drive storage and even SSD. And what we're seeing is as our customers in this space are dealing with more and more high-res content, and they have a need to add more VFX, do more rendering, and especially in today's climate, a lot more transcoding, to distribute content over different channels and that. The attributes of NVMe and the performance attributes that it has are making it kind of the go-forward choice for that tier 1 production storage.
Right, absolutely. If I remember correctly, NVMe, its bus protocol is very different, right? It's connecting through the PCIe bus, and it doesn't have a traditional storage controller like SAS or SATA, right?
Correct, yeah. Bypasses some of those elements, and in some of the legacy kind of storage array architectures, things like a storage controller or a RAID controller can actually be a bottleneck. Mm-hmm. And NVMe kind of gets around that. It's reading and writing data directly to the storage devices. And that's what allows us with our products and others to kind of achieve some of those performance advantages versus, most of the current technologies that are deployed out there today.
Right. The way I typically like to think of it is instead of, in your typical commute, like say, imagine your hard disk is your car and you're driving to work. In your typical commute with a traditional hard drive or even a traditional SSD using a SATA or SAS backplane, there's a couple of stops like Eric was mentioning where we're going through a RAID controller, we're going through a device controller, and if we're driving, that's a car, we're stopping at stop signs and going through, waiting for various traffic. But with NVMe, it's kind of like you have an on-ramp to the highway in your backyard and you just go.
Yep. Yeah,
Right.
I like the analogy and kind of building on it. I mean, one of the other new technologies that kind of goes hand in hand with NVMe is RDMA, which is really more of a networking technology, but there's a strong parallel and the two work in concert. So Ben, with your analogy there, it's kind of like with legacy, kind of more of a TCP IP based protocol. I'll try to think of it. It's almost like you've got a lot of friends in your car, but you're stopping every block just to make sure that they're all there. And,
Right.
and,
Are you buckled in?
And,
you okay, buddy?
Yeah. And, with RDMA, what it's allowing our customers to do is achieve very low latencies on an Ethernet-based network, right? I mean, the spot we come to, a lot of our customers are still on a fiber channel SAN. And, where customers have that infrastructure, that's great. It's very low latency. But going forward, more and more customers are moving to an Ethernet-based infrastructure. It's less expensive. It's less complex. And using RDMA with NVMe is one of the ways that they're able to do that and still do all the work they need to do and, ingest all the content that they need to do. So those two kind of work in concert. And we're seeing a lot of good adoption in this space, a lot of interest, even through COVID, actually, a lot of people investing in this tech.
For sure. Yeah.
Go ahead. Let's just take a quick pause and define what RDMA is, just for our listeners. So RDMA stands for Remote Direct Memory Access. And Ben, it's kind of like a mind meld protocol, right?
Yeah, we're fond of calling it that, for sure. If you're a Trekkie and you remember our friends, the Vulcans, and they do the Vulcan mind meld, obviously a remote direct memory access, my thoughts to your thoughts, your mind to my mind, or my mind to your mind. In this case, it's my memory buffer to your memory buffer, my data stream to your data stream. RDMA bypasses the CPU. And so it takes a much more direct route and can also bypass that networking layer and TCP IP like Eric was mentioning. So it's wickedly fast and super cool.
So it sounds like it really is a good pairing for NVMe because we're sort of bypassing all of the things that, the switching protocols, as it were, that kind of can slow us down.
Yep. Yeah, and that doesn't mean that at some point in your storage stack, you're still going to be using TCP IP somewhere. But it just means instead of using those traditional layers on the back end, like RAID controllers, that we're going a heck of a lot faster through those gates than we would have otherwise.
Yeah, it's all about, we're removing bottlenecks in either the network infrastructure or the storage infrastructure. And, Ben, I think you said it. Hopefully we get a chance to talk a little bit more about this. But with our StorNext customers, what we're seeing is that, as you said, many users of the data on the storage, they may still use TCP IP or traditional NFS or SMB access. It's fine. Maybe they just need to review low-res versions of footage and sign off on it. But where you have, colorists working in 8K RAW at very high frame rate, you get their workstations connected directly to this NVMe storage, and they're just able to produce more. And it is orders of magnitude faster.
Now, when you're talking about connecting their workstations directly, are you saying that directly to the back of an F2000 or an F1000, we can just plug in our Ethernet NIC and, our colorist is maybe 25 or 50 or 100 gigabit connected to the back end of the storage?
Yeah, direct connected can mean different things, but this is also part of the magic of what we do with StorNext,
Sure.
where using our StorNext file system client, they can actually connect their workstation over the network directly to that backend storage. And the underlying protocols of RDMA as well as NVMe, like we talked about, you're bypassing all these other things in that chain that would have been a bottleneck. You're not using a chatty TCP/IP protocol.
Right.
The networked storage looks like local memory from the perspective of your workstation. Now, you need a new NIC to do that, right?
Mm-hmm.
There's new NICs to do that, and you need some switching infrastructure. And so that's part of the investment people are making. But for our product set, at least, we're seeing NVMe deployed both in fiber channel SANs and fiber channel environments, as well as in these new Ethernet-based environments with RDMA and those protocols.
Are you seeing a lot of DLC with that?
Yeah, it's a mixture of both. It's some kind of direct connection and some kind of through a proxy of some type. So
Gotcha. So
Ben,
yeah.
what's DLC?
DLC is the... what does the D stand for, Eric? I know it's the LAN client, but...
Distributed, yeah.
Distributed.
DLC is a StorNext distributed LAN client.
Right.
So it's a way that users can connect to a StorNext file system cluster over the LAN, right? And it's something that, I think we probably haven't talked about enough as a company. It's one of the things that makes StorNext very unique. And it's one of the reasons that the file system is so widely used in media production and post-production.
Right, because
Yeah,
it gives you
absolutely.
some of those benefits that you traditionally get with a fiber channel SAN, meaning that we're talking at a block level. And for those of you who are new to Quantum and StorNext, StorNext is the file system, which is a block level storage area network, wickedly fast, probably one of the fastest file systems in the world. It's a clustered file system, so multiple RAID array, multiple storage chassis are all available, sitting on your desktop, all humming together, hundreds of hard drives or dozens of NVMe drives, or both all together as one, sitting there as one icon that might go somewhere like 25 gigabytes per second, which is light speed.
Right. And that's the key there, is that it's that single namespace, that single volume on your desktop that you'd be working off of in a production environment. There are many other very, very fast file system types out there that can scale out like you can with StorNext. They just do it in different ways.
Yep.
You may end up adding separate volumes, things like that. So
DLC, it's a piece of software that is either part of your OS in the case of a Mac, or it's a piece of software that you would install for Windows or Linux. And it allows you to access the block level storage over the Ethernet switching. And Ethernet is a little bit cheaper than fiber channel in these days, maybe even a little bit faster.
Yep. Yeah, the way I think about it is, it's maybe not 100% technically accurate, but I think everybody is familiar with an NFS client or an SMB client because it's just built into the OS.
For sure.
And those clients use TCP/IP as kind of one of the underlying protocols they use to send data between a workstation and storage. And it's great for most types of data, but it's got overhead. It's hard to get really low latencies with that stack of things. Our alternative would be, we use a StorNext file system client. We also support NFS and SMB because people need that too. But for the really high speed work, the really low latency work, we would use our file system client. And then in the case of what we've been talking about, we're using a flavor of RDMA to send the data back and forth. We're using the NVMe as the storage and the very high speed flash storage. And so it's a much more efficient kind of stack or chain. And it's why we can achieve the streaming performances of, 25 gig a second and upward. Actually, we're going to improve on that again this quarter. And I think hopefully say definitively we are the fastest file system on the planet by a long shot. So maybe that can be our next workflow show.
There we go. That sounds good. Right. So along with NVMe, obviously, the physical footprint of a volume like that, by way of comparison to traditional hard disk drives, is radically different, right? So,
yeah.
If we had a fiber channel SAN, right, and we wanted to reach 20 gigabytes worth of performance, we might have something like, 4 of the QXS 484s, and that would take up 20 U of rack space to provide that kind of storage, versus something like an F2000 with 24 NVMe drives that would give us 25 gigs of performance, and then it would maybe be, 2 U?
Yeah. Yeah, you're right. I mean, it's one of the other benefits of NVMe. This is one of the other reasons that we're seeing companies in media invest in NVMe, right? So recapping a little bit, the first is just that everyone is dealing with more high resolution content.
For sure.
Right?
Mm-hmm.
More 4K, more 8K, and at high frame rate. And they're typically ingesting it raw, and then we create proxies and, do different things. But one of the initial customers of ours that deployed NVMe, they upgraded their entire editing environment to all NVMe, 100% NVMe. And you don't have to do that. We're going to talk about some things that are new in StorNext and that allow people to kind of mix NVMe and hard drive storage. So you can kind of think about, our customers can kind of deploy a little pool of NVMe storage, maybe for their colorists or for their, high-end editors or something, but keep the bulk of their production data on hard disk, which is less expensive.
Mm-hmm.
But anyway, this customer upgraded their entire production storage environment, and they were able to reduce their storage footprint from 3 full racks of hard drive storage to 14U of NVMe storage servers, right?
Wow.
So that was 7 of our F2000 series. But, when I'm out talking to customers and partners, there's almost this initial perception where people are like, yeah, I love NVMe, but it's just too expensive for me.
Right.
And what we're finding is it actually is driving some cost savings and business line benefits in other areas that really offset that, right? I mean, one of them is reducing that data center space.
Yep.
The correlated one is think of the power and cooling savings
For
that
sure.
are associated with that, right?
Yep.
And it's maybe worth double clicking on a little bit too, Ben, so the audience understands that the reason that customer had so many racks of disk was that they needed a very large number of spindles to achieve the performance that they needed to do their work. And because of the performance advantages of NVMe, everything we've been talking about, they were able to shrink that footprint by, whatever that is, 80%.
Yeah.
And that's power and cooling savings, it's rack space savings, and that's expensive. Data center real estate can be expensive. So, we could talk about some of the other things like reducing fiber channel port counts, right? Which has a real concrete cost savings, or maybe moving away from fiber channel altogether.
Yep. Right.
Right.
Let alone just the increase in productivity that it can drive for customers' workflows and customers' media pipelines. I mean, you have your creative teams can get their work done faster. If you're a post house, you're completing projects faster. You can take on more projects, So, I mean, these are even kind of through COVID, these are some of the reasons why we're seeing such interest in NVMe. It just has a really good value proposition.
Yeah, awesome.
That's great.
That total cost of ownership, or TCO, goes way down when you're dealing with a whole lot less power and cooling, as well as things like your support contracts, right? Because if you've got 4 RAIDs to deal with as opposed to 20 RAIDs, the yearly upkeep on that is a whole lot lower. So there's a hidden benefit too to consider.
Yeah, that's something that we should just make sure we call out specifically. If you're pricing out an NVMe storage solution, think about those things that might go away and that TCO. Like we said, that rack space, that heating and cooling, cooling mainly, and then that support contract cost. So just keep that in mind.
Right. While we're playing the acronym game, I know we've thrown out TCP/IP a bunch over the last couple of minutes, so we should probably define that too. We're always up for making sure people know what the heck we're talking about, because you may be an IT expert, you might be a video editor, who knows, right? However you came here, thanks for spending time with us. So TCP/IP is Transmission Control Protocol, or Internet Protocol, and that's how we're talking together over the internet right now, or how we search for all those great cat memes, or even watch great videos and enjoy Netflix like we do on a daily basis.
Yeah, basically that backbone of communication that we are all used to seeing is all TCP/IP based.
Right. And Eric had mentioned when we were talking a little bit using our CAR acronym about checking to make sure everybody was belted in, TCP/IP in terms of a protocol, its job is to make sure that those data packets arrive from point A to point B. So if the path or the street is not 100% clear, and it runs into, bumps in the road and it has to slow down, or in multiple hops across the internet, that's when we can drop frames, if we're talking about a video editing workflow, or when we're watching each other on Zoom and our video and audio starts to get garbled, or we're watching Netflix and the quality goes down. That's why, largely in part because the protocol was created back in the early 70s, maybe a little bit earlier, largely in part to make sure that our allies in Europe were still there after a nuclear war. The idea is to make sure that those data packets go from point A to point B successfully, and so that we can make sure that the information gets there. It's not about speed at all. So using it in places where we expect to have a lot of speed, we have to make sure that all of the conditions are perfect, meaning that we haven't a switch where we've got gobs and gobs of bandwidth, and if we need buffering in that switch to make sure that packets aren't lost between the storage and your workstation, that all of that happens. And anyway, I digress. Let's talk about more.
Well, I guess we should talk about the F-Series a little bit, right?
Yeah. So Quantum has two models of that F-Series storage, Eric, right? The F2000 and F1000. And they're both a little bit different. Performance is kind of the same. The F2000's maybe a little bit faster on writes. But why don't you tell us a little bit about that?
Yeah, so first off, we introduced the StorNext F-Series last year at NAB. So it's been out in market almost a year and a half now. Very strong adoption, almost all of it in media production and post-production. But we're now starting to see it being deployed outside of the media and entertainment space. We can talk about that more. But yeah, the initial product we introduced was an F2000. It's a 2U NVMe server designed to be deployed as part of a StorNext file system, 2 controllers, failover, kind of high availability, everything. And a good example of, one of the initial customers there, like I said, they upgraded their entire editing environment to these boxes, so they're seeing great results, very happy. And as we got into the market, we were starting to hear from customers and partners that they said, hey, I love the value proposition of NVMe. I don't always need it to be the most highly available device.
Right.
So we have some customers where this is another great real world example where they were doing a large multi-node render job on a StorNext file system with a bunch of disk. And it was taking them almost a day to complete the render job. And they put in a little bit of NVMe. Same render job gets done in 30 minutes. Just because NVMe is so much faster.
Just sprinkle on a little NVMe and
right.
your job is reduced by 23 and a half hours.
Right. And in this particular case, this was a post house, they're not rendering 24/7. You guys know sometimes people are using the cloud to do burst render and some of this stuff. But for them, they're like, look, it doesn't need to be highly available, but I'd love to just put a little bit of NVMe in my environment, get that boost, see that benefit. And so right at the start of this year, we introduced the F1000, uses the same software that's on our F2000. It's just a lower cost, 1U server, 10 NVMe drives. And the entry point of that is about, I don't remember exactly. I want to say it's about 35 to 40 terabytes. It's not much. So we're now seeing a lot of customers that are, just purchasing one of these, and they kind of almost put it in front of their current storage environment, if that makes sense. Like if their current disk-based storage or SSD storage is their tier 1, call this a little tier 0, right? And they give it to their colorists, or they give it to their editors that are working in 8K, or they use it for render jobs, and it just gives them a boost for whatever step in their workflow they need. So
I love it.
Yeah, we've got the 2 models. We're going to be enhancing them again toward the later part of this year with new software enhancements that actually speed up performance even more. So we've been really pleased with the adoption so far.
Now, speaking of software, one of the things that makes this possible, right, because we still need some traditional data protection services like RAID and trying to make it highly available, in the case of the F2000. So there is a software-defined layer or a layer of virtualization that happens on top of that that you guys have really kind of jumped into and are kind of working in both the present and the future of storage topologies. Can you tell us anything about that?
Yeah, this was actually one of the things that we did just kind of almost under the covers in the last year and a half. But we talked earlier about how, dedicated RAID controllers, some of those things can be bottlenecks in more the legacy architecture, but you still do need that data protection. So we developed our own software-defined block storage stack. We actually made a very small acquisition about a little over coming up on 2 years ago, integrated some technology and some people, and then built our own software-defined block storage stack based on that. And the first place that came to market was with the F series. So we use that as kind of that underlying block stack. And then we use it with a different product line we have focused on video surveillance. And when we think about where we're going with StorNext, we are moving to a totally software-defined architecture for StorNext. And this was one of the technical building blocks or stair steps that we needed to get there. And so you're actually going to see that in the future of StorNext when we go to StorNext 7 and beyond, that we're moving to software-defined everything. So.
Yeah, I mean, that seems like it's very much been the present in a lot of the more advanced big data cloud workflows that we see, but seeing that it's coming to something that we might use in M&E and start to trust in environments like that is really exciting.
Yeah.
Yeah, for sure.
Yeah. Frankly, one of the things that makes it unique is, this is a little technical, but if you think about most of the storage arrays that are out there, they were designed for enterprise IT workloads, right? They were designed to run a database really fast. And they have a bunch of really fantastic data services that were built for those type of data sets. But this has allowed us to build a block storage software that was really optimized for this type of industry where it's really about streaming performance.
For sure.
I mean, things like compression, things like dedupe. I mean, these little data services that go in the code stream, we don't care about that here. We've stripped all that away.
Right.
We have a very, very fast block stack, and it's why we can achieve the performance that we can achieve.
Right.
So it's allowed us to kind of design something that I think is more specific to this industry.
Right. It's got to be a flamethrower.
Right.
Yep. I mean, other good use cases for NVMe might be something like high frequency trading or genomic sciences, anywhere we need to crunch a ton of numbers as fast as humanly possible, right?
And we can't have the storage be a bottleneck.
Right.
Yeah. And our go-to-market with this product is that we sell it with StorNext. I mean, I would think about it that way. So this is NVMe storage for our StorNext file system. And our StorNext file system really excels with big files when people are dealing with big unstructured data. And obviously, media and entertainment industry is a great example of that. The other industries or other types of data where we shine would be things like, genomic sequencing data, which is basically a series of very high resolution images.
Right.
MRI images, CAT scans, satellite imagery. When you think about these use cases, it's customers, they have some device that is creating these very large files and it needs to be ingested very quickly. And then they have a stage in their workflow, if you want to think of it that way, where that data needs to be worked on. You have a bunch of very highly paid, highly skilled creative people that need to collaborate based on that data. They produce some result. In the case of media, you produce a finished copy and you distribute it. And then you need to archive it forever. And not for 7 years for Sarbanes-Oxley, but like forever, right? And that pattern, that use case is where what we've designed our whole product set for. So one of our customers we were talking about prepping for this workflow show is actually in healthcare research, and they're now using NVMe. They have a repository of over 300 million MRI images and CAT scans, basically medical images. And they're using a GPU cluster now to analyze those images, to look for patterns, to kind of find cures for diseases and stuff like that. So one of the studies, this always helps me kind of think about it to bring it to life, pretty interesting. They have MRI scans of a bunch of different, let's say, athletes that have had head trauma. So they can look at these scans and they can look for patterns to try to figure out maybe how to make helmet design
Right.
Things like that is just one example. So in that case, with NVMe, it's really about the performance that it's able to feed to that GPU cluster.
Yeah.
Right? And again, it's outside of media and entertainment, but we're starting to see those use cases as well.
That was actually something that I really wanted to ask you about. And the discussion sort of naturally moved to that, which was, we are very much aware, we, CHESA, are very much aware of the M&E offerings of Quantum. It's kind of been one of the things that we've spent lots of time looking at and working with you guys on. So I was really interested to know, like, some of the other industries that you guys work with. And you just mentioned the healthcare MRI space. You mentioned satellite before. Any cool stories there?
Yeah, I mean, in the U.S. government, the Canadian government, the French government, all of their agencies are capturing a massive amount of satellite data to study the planet. The agency over in France is ACRI. They're one of the European space agencies. They're a public case study of ours. But yeah, they're actually using some of that imagery to study the effects of climate change on the planet. And, StorNext has excelled in those types of use cases for many years. And I think that with Quantum, if you kind of think about the path we're on with our portfolio, we added NVMe to be, which we think NVMe is the future of production storage. Right? I mean, that'll be gradual, but it's already very similar in price to SSD storage arrays. So pretty quickly, production storage is all about NVMe. We acquired the active scale object store business because we think the future of where data is going to live is going to be object storage. And we're going to put tape underneath it because we think that where data is going to live for 100 years is probably still tape until it's DNA storage, right? So,
right.
So you kind of seen us built this stack of products, which we now have in market. And the use case I described is really applicable in almost every industry. Any industry that's dealing with massive unstructured data, we have, I think, the best technology stack for that now in the market, of anybody.
So, Eric, you've mentioned that phrase before, unstructured data. Why don't you?
I was going to go there too. Yeah.
Yeah. I mean, it's essentially anything that's not in a database, but why don't you go into it a little bit more?
If you simply think of the data world, you have structured data, which is something like a database, rows and columns, very searchable, pretty straightforward. Unstructured data is generally file data. And the biggest subset of unstructured data is video and images.
Mm-hmm.
Now, a lot of video and images are for maybe entertainment purposes, but not all. I mean, there's a lot of video that comes off of a drone or a satellite, or an autonomous vehicle produces a huge amount of video and video-like data. And that's really our focus. I mean, there's some unstructured data that's things like, log files or text files or things like that. That's not really where we play, where we hunt. We're really focused on video data, image data, and that is the class of data that is growing much faster than anything else out there. It's harder to manage. It's harder to search. It's harder to extract insight from it. And I'll say this one more time. The thing we're starting to emphasize more is we're finding it has to be kept forever.
Right.
And maybe not, we're starting to talk about this idea of like a 100-year archive, because we've been dealing with this problem in media for 20 years. How long do you need to keep the original digital content of Star Wars?
Oh, forever. Indefinitely. Come on, it's a masterpiece.
And it's like, one of our customers, the National Institute of Health Clinical Center that we were talking about, they want to keep those MRI images, that medical image archive forever, either because of patient reasons or because they want to have a corpus of data that they can mine in the future using AI and ML type of technique, artificial intelligence and machine learning type of techniques.
For sure.
To get new insights and new results. So.
Right. Show me everybody who had this thing wrong with them, and let's try and correlate some sort of information to get to a curative response rapidly.
Correct. Quantum's a member of the sports video group, and I've been at many panels there. And one of the sayings that I've heard a lot in that industry is they're kind of like, the content in your archive isn't valuable until it is.
Right.
You never know when that's going to be, and so this idea of being able to build these extremely durable, searchable, forever archives, that is like what we do. And we're seeing more deployments of that. So, we're kind of hopping around, but it's like we definitely see that where data is going to work is going to be high-speed file and block on NVMe.
Mm-hmm.
And where data is going to live is going to be these massively scalable, searchable archives, and being able to move data to and from and classify it. I mean, that's kind of where we're,
Yep. Us too.
All right. So, Eric, thank you for bringing us up to speed on sort of the future of production storage. That's really fascinating. I want to switch the discussion a little bit to going into the object storage and sort of cloud integration part of where we're going. So let's start with that sort of transitional phase of moving files in and out of object stores from sort of production through to maybe an on-premise cloud or maybe even just a full-on cloud object storage. Where are we going there?
There are a couple different angles to that. I mean, one is we know the future is hybrid cloud, and we know the future is going to be multi-cloud. And we already have many customers that are doing both. So one of our StorNext customers, a case study that we're working on, not published yet, large broadcaster over in Europe. And they have a StorNext environment at their main studio, which happens to be in London. They have Avid and they have Adobe editing suites that connect into that. They're using a Google Cloud archive service to house all of their kind of raw content. And they use their asset management software to direct the StorNext file system to move files and move directories between that cloud archive and their on-premise. So they might bring some raw content back on-premise. They might produce some new material from that, send it out over social channels, and then expire that and kind of leave the raw content in the cloud, if that makes sense. And we have customers that actually do kind of almost the reverse in different ways, where they may push some content up to the cloud, and then maybe they do a quick render job on something or a quick transcode job, and then they just expire it. And I said a lot there, but StorNext for the last several years has had very good integration with both cloud-based object stores as well as on-premise object stores. And, obviously now with Quantum ActiveScale, we've got very tight integration with that object store. But, we support AWS S3, we support Glacier, Deep Glacier, Microsoft Azure, Block Blob, Google Cloud, Wasabi, the list goes on and on. But
right.
So we have many customers kind of using StorNext as the means to move files and move folders between an on-premise environment and the cloud and back. And we think that increasingly people are going to want to use different services from the different cloud providers, because that's a whole nother competitive battlefield. You might want to use the Google render engine, but you might want to use the video indexer from Azure because it's better, and
right.
Being able to have that choice, that flexibility to move between on-prem and cloud. I mean, we think that StorNext and Quantum kind of being the orchestrator or kind of the engine to help you do that is kind of where a lot of the future is.
Yeah, I wouldn't disagree.
Absolutely.
We talked a little bit about the future being more software defined. And one of the things that we're a big fan of and that we talk about here often, and we will talk about more in detail later, is REST APIs, right? So if we can talk to even the storage layer and say, hey, give me this, or I'm gonna give you this, give me this back, right? And get more information and share more information at that command level, that just helps us automate everything and make everything that much easier to use, even though it might be a little bit more difficult to set up.
Yeah. Imagine if your file system had an API, a REST API that you could send commands to and receive commands from, and that could be integrated in some sort of a automated workflow process. That would be pretty darn cool.
Yep.
It's one of the things StorNext, has had for many years, pretty tightly integrated with a lot of the leading asset management software applications out there.
Mm-hmm.
And, and then in terms of kind of a RESTful interface or API, that is one of the reasons why our customers in this space are looking at object storage. And storing content in an object format has some advantages. It can be more searchable because the metadata can be embedded within the object. And where you have applications or where you have steps in your workflow that lend themselves to using that type of an S3 interface or RESTful interface, object storage is great for that. And that's kind of where we're seeing it. I mean, some workloads still have a file interface, and I think they will for a long time. Some use an object interface, and we can kind of deploy the right solution based on what people are trying to do.
Right. Now, it's worth redefining a little bit. We've talked about object storage in one of the last episodes in the M&E Basics series. It's worth, again, stating that an object storage or something that uses storage buckets, they typically call that, because it's a flat file system, right? Where we're throwing a bunch of objects or files into a container and then giving them unique identifiers to say, oh, I want this file back, and we've got this hash, so hey, here's the key, please give me my file back. One of the recent developments, I think in StorNext 6.4, is that you guys are adding a little bit more information in and around the object metadata that will make it easier for people to use object storage in the future, right? By allowing us now to say, also include the file system path in the object data, right?
Correct. Yeah. With StorNext 6.4, we introduced two things related to object storage. The first is self-describing objects. So when StorNext moves a file to a cloud-based object store like S3, we're doing that file to object kind of translation, like you mentioned, Ben, right?
Yep.
And prior to StorNext 6.4, we were able to move objects and store them up in the cloud. But if someone wanted to use that object for some reason, if they wanted to search it or run some service on top of it, they kind of had to bring it back through StorNext first.
Right.
With self-describing objects, they can now use just off-the-shelf browsers, different scripting tools or whatever to be able to access that content right out of the cloud. They don't need to do that through StorNext. And so for use cases maybe like DR or maybe sharing content, in some cases it can work. We'll come back and talk about that more just quickly. The second thing we introduced was we actually improved the way that we can do reads and writes of data to and from an object store. So we actually really improved the performance that users can expect for StorNext kind of moving data in and out of an object store. So both related to that. And I think both could apply to either an on-premise object storage system like ActiveScale or public cloud object stores, in a more of a hybrid cloud workflow.
For sure. Jason, one of the first things that I thought about, given these self-describing objects, is something like Iconic, right? Where we've got a cloud-based MAM that could be a really accessible front end. And so if we had a StorNext SAN in our production environment, but we also wanted to share things front-facing via the MAM, if the MAM could access that same bucket that the file system was moving things into or replicating things into, that would make certain things really easy, wouldn't it?
Potentially, yeah. That sounds like a very solutions architecture-y story there you just told.
It does.
And it was a very systems engineer answer.
It was, yeah, exactly. And that's
this whole topic. Sorry to interject there a little bit, guys. This whole topic is so top of mind for people with COVID, right? I mean, everyone is focused on remote online editing, and I think you've seen this in your industries. I mean, COVID has kind of been an accelerant for where the industry was going. It's just that I think we're going to get there in 1 year, not 10.
Yeah, exactly. We have actually been talking about this for the last few months here on the show about how fast everything went. Eric, we just did an episode in November, December of last year about like the future of cloud editing. Right. And it was outdated in a few months, like completely outdated. We were talking, the episode was very much about what is possible today and, the perception versus the reality and like, when will this be possible? And we kind of just blew that out of the water 3 months later.
You got it.
So
it forced people to get creative, and what our customers have found is, they were forced to set up a studio in the cloud, right? And now, maybe that wasn't a blockbuster movie, but maybe for their news team, right? And they were forced to do it. And guess what? It worked,
Mm-hmm.
So we talked about what we did recently with StorNext. And again, it's kind of these building blocks for the roadmap that we're on. I mean, our next step is to bring to market where you can actually set up a studio in the cloud or a file system environment in one of these clouds with StorNext. And we actually have that deployed at a couple of customers already, I would say in kind of a beta. But I mean, they're running StorNext in the cloud. And that'll be something you'll hear more from us, as we go forward on our StorNext roadmap, because clearly an area of a lot of interest from a lot of people.
So StorNext in the cloud.
Are we allowed to ask questions?
Yeah, I was going to say.
Yeah.
So if
Go ahead, Ben.
I mean, the imagination wonders, right? If we're spinning up a SAN in the cloud, if we've created essentially virtual machines of our metadata controllers, and we're talking to storage layers, because in a SAN file system with StorNext, we've got to have a metadata, right? Because the data about the data for the file system, all of the inodes, essentially like the roadmap or the treasure map to where your files live in the file system. That's what makes it so fast, and that's what also protects people from overwriting each other's files, is that we have this wonderful file system metadata that's got to live in its own little chunk of storage or on a stripe of storage. So, and then we've got the block storage, right? So all of these different storage components go into the StorNext file system to make a SAN environment. So in order to be able to press a button and spin up a SAN, which is essentially like the awesome futuristic robot version that we're talking about here, everything would have to be living on some sort of a hypervisor and spin up like magic. Tell me secrets, Eric. Tell me.
The way I'd think about that is a series of stair steps, and I think it'll help point the path for where we're going, right?
Okay.
We started talking about F-Series, and one of the things we did was we developed our own software-defined block stack.
Right.
And we've also developed a very basic hypervisor, and we're using that today on some other products that we sell.
Now, a hypervisor is what?
A hypervisor, think about it as a layer of software or virtualization software that can host multiple guest VMs, right? And converge those and run them on a single physical server. I didn't say hyperconverge, but let's just say converge.
Sure.
Now we've got all those pieces. You can say, well, okay, it's pretty easy for me to imagine that when we go to a fully software-defined architecture with StorNext 7, we can actually run StorNext along with the block software and all the components we need on a single 2U server, right? And we run think about it, we run StorNext in a VM.
Right.
Earlier, we talked about the F2000, which is a 2U NVMe server.
Right.
It runs quantum software. It's got 2 controllers. You can actually envision running an entire StorNext file system on that F2000, one box.
Right.
Now, that's for NVMe, and we're going to have other boxes that have hard drives and all that, but that's not too far out. That might be our next workflow show where we talk about this maybe next quarter.
That sounds awesome.
Once you get to that point, it's a pretty easy next step and say, okay, if I'm running StorNext as a VM on a hypervisor, it's actually not that hard to run it as an AMI in AWS or run it as a VM in Azure, right? And that's kind of the concept. Yep. How it's architected, how the MDCs and all that, I'm not sure of that yet, but I think hopefully that helps give you sort of the path, and for the listeners out there, you kind of understand where we're going a little bit technically. And
yep.
We'll be making some announcements here. I mean, the expectation would be early next quarter. We'll be making some announcements around this. So.
Super cool.
Awesome.
Workflow Show.
So speaking of the future, and I'm talking about StorNext 7, let's talk about file system pools a little bit. Best of both worlds. What are we looking at there?
This is kind of a new data management capability that we're adding in StorNext 7, and it was really driven by NVMe, I have to say. I mean, so because we think the future of production storage is around NVMe, and we want to enable our customers to take advantage of that, but we don't necessarily want to make everybody have to upgrade their entire production environment to NVMe, right? It's not economically kind of viable, maybe. And so we had a number of customers that said, look, I want to deploy some NVMe in my production tier, but I may want to leave my existing storage investment in place because the storage arrays I have today are fine for 80% of the users, but the 20% really need that performance boost. So, okay, got it.
Right.
What we developed was a new capability in StorNext that we call file system pools. And there's two components to it. First is it allows a system administrator to define pools of storage within a StorNext file system. So for example, you may define an NVMe pool and you may define a nearline storage pool, right?
Or hard disk drives, right?
Or hard disk drives, right? Yeah, and then you can kind of assign specific users and clients to that using the features that are in StorNext. The second component of file system pools is a policy engine that allows an administrator to then, once the pools have kind of been defined, you can then define policies that say, okay, I want to move this file or this directory between these pools of storage. StorNext manages all of that under the covers. So to a user, to an editor, or to a colorist or a visual effects technician, they don't see this stuff moving around. It just looks like their local drive. But the file system can be moving this data in the background. So one way that customers are using it today, because this is deployed in production and some select accounts, is I guess I talked about these examples already. You may have a colorist that needs to finish something and you just promote the files or directories that they need to work on. You promote it up to the NVMe pool. Right? To them, it doesn't look any different. They just get a lot faster performance. When they're done, you can promote it back down.
Right. Or maybe the ingest operation just always first goes to the NVMe pool because we know it's a new hot thing, a new hot project, and maybe we can set a policy on the back end that says it's been there for a month, nobody's touched it, demote it, right?
Yep, and then demote it. Yeah, and those are examples of policies that administrators can set. You can kick off a job and move data, move files or directories. You can use APIs and all that, script it and everything, but you can also set policies based on time, based on certain thresholds and things like that to be able to move between pools of storage. And so really what it enables is it enables customers to start to use NVMe, get the benefits of it, and start to build a production storage environment that's, partially NVMe, partially these lower cost types of storage, and then migrate to, the future over time.
So this is great. I mean, this opens up a lot of possibilities. You mentioned this can be done with REST APIs. I mean, I imagine it could also be done with a GUI and other ways too. But with the REST API, that gives us the capability of hooking that into some sort of an automation or orchestration platform or a MAM with that functionality. And, really sort of drive that based on where things are in the process, if we're tracking the process through that project.
Exactly right. I mean, there's so much we're doing in StorNext 7. There's so much we have going on. We have a new simplified user interface. I mean, it is a dramatically simplified user interface.
Right.
And this setting these policies for file system pools, we can show that today. We're demonstrating that today. So you've got that option. And then, Jason, right on. I mean, this is integrating with asset management applications or other kind of orchestration tools, make it really easy to do. And we've got a good long heritage of doing that. Actually, we won a technical Emmy for that at the start of the year, which was kind of cool for our contributions in the fields of data management. So that was neat to be recognized that way. But
so
that's great.
It's worth mentioning too that you guys have had a policy-driven hierarchical storage management layer for a long time in Storage Manager, but this is something completely different, right?
Yeah, I was just going to ask, how is this different from, say, Storage Manager moving data to the cloud or to tape or maybe an Affinity?
Yeah, this is something totally different. So Storage Manager was really designed many years ago, and that was really about moving data to tape.
Okay.
And, that's where we've got a lot of customers that still use digital tape for their archives, and it's an important thing of what we do. But we've built on those capabilities over the years to be able to tier data off to different secondary storage targets, and that might be active scale object storage. It might be AWS or Azure. File system pools is really all about moving data within the primary file system. So it's a different layer. It's a different policy engine as well, actually. And the benefits of it are just for simplicity, and it's really all about enabling NVMe, I would say, more than anything else, as that go forward tier of production storage, right? Being able to move data seamlessly between NVMe and hard drives and just boosting performance.
And this is going to be something that's part of StorNext, right? It isn't an additional license. It's just going to be a huge value add for customers.
Correct. Yeah.
Awesome.
Correct.
I think people are going to be really excited about that.
One thing I will say, and when we moved to StorNext 7, we're moving to a software-defined architecture technically. We're going to move to more of a software-defined business model too. We're actually going to be simplifying our licensing and, allowing people to consume the software more like they're used to consuming maybe other software applications they do today, as a service and a subscription-based type of thing. So we're going to have some new licensing options that we'll introduce with StorNext 7.
A SAN as a service. God help us.
Yeah, you've said that a couple times now. I don't refer to StorNext as a SAN. It's a file system.
Sure.
It's a file.
Yes. Right.
So,
old school SAN guys.
SAN as a service, yeah, maybe.
That's how we got into this game. That's what Quantum has always been in the back of my brain. So obviously the StorNext file system is the heart and soul of Quantum's business, but you guys do a whole lot more. So yeah, for sure.
Yeah.
Yeah. And yeah, it's also going back to the cloud conversation. I mean, it's easier to think about. I would never say our plan is to deploy a SAN in the cloud. I mean, maybe, but deploying a file system in the cloud, yeah, we're going to do that.
Mm-hmm.
Right. And SAN is a storage area network, right? We still build them these days if people still need wickedly fast block level storage in the case of Fiber Channel. But I always just think that the concept of a storage area network, for me, it's akin to what we're talking about in terms of hyper-converged, storage, right? We have all of these multiple ins and outs and various protocols that we can bring. Just the terminology kind of sets my mind to wondering. So that's kind of what my brain does with that term.
Yeah. Oh, right on.
So we talked a little bit about private cloud and ActiveScale. It's probably useful just to talk a little bit about a couple of use cases. We talked a little bit about that in the past in our second episode of the M&E Basics series. But in terms of what you guys are using ActiveScale for, where do you see great user adoption for that product?
In a kind of a marketeering way of talking about it, we're seeing that high-speed file and block is where data works, and object storage is where data lives.
Mm-hmm.
And it's also, you could say it's where data lives and maybe, lives for a really long time. Almost all of the use cases for ActiveScale that we see, it is a very large-scale content archive. It is a content archive. In media, it's a content archive. Outside, it may be an active archive. And this may be because of Quantum's portfolio, but most of the deployments with ActiveScale, we have a StorNext file system cluster in front of it.
Sure.
Right. So people are using StorNext to, do their work, to ingest the content quickly. When they're not actively working on it, we can move data to the object store and it's protected, right? It's a self-protected object store. And if they need to bring it back, they can bring it back and work on it. And they can also directly access the object store for other things and other reasons. But most of the time what we see is ActiveScale being a kind of very large-scale content repository.
Yep, that makes total sense.
We've got, good adoption in media and entertainment as a content repository, sports and sports production. A lot of big sports content archives are based on object storage. And then outside of that, it's genomics research and life sciences. We do see, financial analytics and stuff where it's effectively like a big data lake. And someone may be running the analytics on some type of a, file cluster, but it's a big data lake. And from that regard, we think ActiveScale is the best. It's got some unique technology in terms of how we place data and how we place the erasure codes that just give it the highest levels of durability, highest levels of performance. And, we have customers managing over 200 petabytes of ActiveScale with a single administrator. Because it's just the system just takes care of itself. And I don't think there's any other object stores that would say that because our software is so intelligent and self-healing and the way it works. So, that's really where we see it shining is it's like billions and billions of files or objects and massive multi-petabyte scale content repositories.
Yeah, that makes total sense. And correct me if I'm wrong too, but having a single object space live across multiple geographies for that kind of bulletproof layer is kind of a good way to think about it too.
Yeah, one of the things that makes ActiveScale unique is that we can actually deploy a single object storage system across 3 geographic sites. Now, not every customer has 3 sites, but for those that do, the way our software works, you can actually lose one and in some cases multiple sites, and we can still rebuild all your data. I mean, That's the magic of the erasure coding software that we do. When you have really, really valuable digital assets, like basically every company, every customer we have in media, the digital assets are their most valuable assets typically of the company.
Yep.
And they need to be preserved and protected forever. And the best practice would say, keep that data in 3 places. That's it's a best practice. Keep 3 copies if you want to think of it that way.
For sure.
Now, when you do that with tape, you've basically today, tape is very low cost, but you've tripled up your tape capacity, right? You put tape in 3 locations, you've tripled it. And at that point, the TCO actually is a little bit better where you say, use an object store system with software, use erasure coding to spread those objects across the 3 different sites. And you have a very, very durable kind of protected against disaster archive, and that's really where we see ActiveScale being deployed. We're going to be talking about it a lot more this year. I think for your customers in media, I think everybody should be looking at an object store based media archive because of its durability and because of, Ben, what you said a couple of times, because of that object interface. It actually makes it easier to search and to index your archive, right? It actually makes it more searchable, more accessible, so that like our customers in sports right now, they've got no new content to show. So they're trying to get stuff back from the archive and repurpose it so they can have things to broadcast, right? So.
And I also want to say that working with an object storage interface, even when we're talking about working with, say, a REST API or something like that, to me, as a workflow engineer, it's much easier to work with than, say, a piece of middleware that manages a tape library.
Mm-hmm. Definitely. Yep.
Cool. Well, there's another product that you guys have recently acquired that I am really excited about. Now, I wonder if we could talk a little bit about Atavium or Atavium. I've heard it pronounced both ways, but...
Yeah, going back to kind of a big picture kind of storyline here, we build our own NVMe products or the software to run our own NVMe products. That's about production. We acquire ActiveScale to have the object store software with erasure coding. We obviously have the tape products, and we're going to bring all of that together in a stack to where we've got all the different tiers of storage you would need to build a 100-year archive, right? And we've already got good data management with StorNext to be able to move files and objects between all those tiers. We actually have a very good orchestration engine. The next kind of big challenge is, well, how do you classify all of that data? How do you make it searchable? How do you make it browsable? And we were fortunate enough in March, we closed a small acquisition of this Atavium source code. And we actually had a couple of their key team members join Quantum's team. So one of the co-founders there, a guy by the name of Ed Fiore, he joined Quantum in March. He's the general manager of our StorNext business and our primary storage business. And the thing that Atavium did that I think was very unique was a data classification and tagging engine. So when files are ingested, they basically get classified and then they get tagged as they come in. And once you do that, it makes the entire file system or the entire repository much more searchable in a variety of different ways that we've kind of talked about through web services, APIs, or through user interface. You can look at a bunch of statistics and all that. And you can kind of see that our intent is to take that technology, integrate that into our StorNext roadmap and bring it to market. And I think this is within the next 6 to 9 months. Maybe 6 months. This isn't that far out. This is pretty near term where you can now build a well-classified and tagged archive where we've got the file, the object, the tape, if you want to keep it there forever, and you can kind of search and index everything. And by the way, even as you're moving data between on-premise and cloud. Right. So this idea of kind of providing that seamless bridge from on-prem to cloud, this is another key, technology piece that we're able to bolt on and that we're going to integrate into our roadmap.
It's super
Very
exciting.
Yep. You guys know, one of the biggest challenges customers have if they have a lot of these unstructured data files on a large scale out NAS platform, if they need to search it, it can take a long time. If they need to understand and get insights into what's really happening with their data, that can take a long time. And I think that's the next thing we're going to solve with this tech.
Yeah, well, it certainly seems that way. And any kind of time savings with the ability of getting those tags up front and then being able to search on anything later, that's really where, that's the kind of thing people are looking for these days. So, yeah, that's pretty cool.
That's the goal conceptually. We talked about large amounts of data being ingested into, let's say, a StorNext file system. Right. So imagine that as that's happening, we're tagging that content and then we can basically classify it a whole bunch of different ways, run analytics on it a whole bunch of different ways.
Right.
That is kind of the conceptual intent of how we bring those technologies together. So,
and I'm thinking that has really huge implications for the sorts of use cases where, this is content that we need to bring in very quickly and just save, in case it needs to be found later for, say, legal proceedings or something like that. So maybe security footage, body cam footage. It sounds like there's a lot of use case there.
A lot of good use cases there. And I think when we think about hybrid cloud deployments and multi-cloud deployments, right? We have customers today that have files on premise, they have objects in AWS, and they have a small editing environment in Azure. We have customers that have that today. When you think about managing that content across multiple clouds, having that data classification engine and then being able to manage data and move data around and orchestrate it, if you will, based on those tags, that's what we're obsessed about now.
Right. It's gold because siloing is a thing.
Absolutely.
Yep.
No, it's super exciting. Being able to do some of the things that we do with MAM in that we pull as much available metadata out of the files themselves, the file extensions, learning what type of media it might be upon ingest into a MAM, who created that, right? What the file path is, any relevant metadata in the file path. All of that stuff comes from the file system. And if the file system is already aware of it and can feed it forward into the MAM, and then if StorNext file system understands multiple silos, multiple cloud repositories that are self-describing, it just makes the end user's experience so much richer and faster, right? Which is just awesome.
Yep.
Cool.
Yep, very cool. Yeah, we're very excited about it. And we're just we're gonna just turn up the volume on everything we're doing because, we've made a tremendous amount of progress in the last 2 years. And I think over the next year, we're really gonna pull away from all the competition. I think people will see that. And I think we're gonna blow people away with everything we've got.
Sweet. I'm looking forward to being blown away.
Yeah.
Yeah.
Not already?
Yeah, absolutely.
Something that we've talked about recently in terms of kind of trying to have a regular segment is asking people, kind of what some of their favorite workflows have been or have seen really helping people, as well as kind of what media they have been enjoying. So, Eric, let's ask you that. What's a cool workflow that you've seen recently that really helped someone?
The ones that come to mind for me recently are the ways where we've worked with partners such as you guys to help customers set up remote online editing.
Mm-hmm.
And obviously top priority. And, that was an area that I didn't know much about. I had to learn very quickly, but
So say we all.
Right.
Yep.
Right. But it was really cool for me to talk to customers. I remember speaking with a few customers specifically, it was in April. And so it was kind of like they had gone through a few weeks of just total crisis mode, right? Can't get, business is shut down.
Mm-hmm.
And they were just coming out of it. And I was talking to them about how they had set up remote online editing. And they were using virtual desktop technologies to access the workstations that were at the studio with the StorNext client, right? So they'd figured out how to use their existing StorNext infrastructure and use these virtual desktop technologies. There's a whole bunch of them out there. They kind of encode the pixels on a screen and encrypt them and send them to the home office, so to speak, right?
Mm-hmm.
But it was neat to talk to them they were sort of hey, we've got it figured out. People are working. We're still doing projects, and now we're kind of cleaning up some things. I guess I really remember those because it was nice to feel like our customers were sort of coming out of crisis mode and getting back to a little bit of getting back to work kind of. And
For sure.
We're seeing that a little bit more even this quarter, that we're starting to see new projects and all that. But yeah, I think those workflows, and we worked with partners such as you guys to help design those, to get them running. And in some cases we had to get some new clients deployed and stuff like that. So that was a pretty interesting learning area for me.
Agreed.
Yep, for us as well, like we said.
And I think related, it's kind of what people are doing in terms of just studio workflows in the cloud. And, we're now working with a couple of our larger StorNext customers now, but they're using StorNext to run editing suites in the cloud. Seems to be working. And I'm really encouraged by that. We got to figure out how quickly we can bring that to market. But, those two things are both in direct response to COVID, and kind of just the industry has just accelerated how quickly they can do that stuff. So That's been pretty cool.
Yeah, for sure.
Yeah.
What's some cool media you've been enjoying during the pandemic?
My favorite customer, Quantum's, is Red Bull Media.
Okay.
And I've got the Red Bull app on my phone, and my little son, who is almost 4, he and I love to watch biking and mountain biking videos on Red Bull Media. We do that all the time. So, it's either on YouTube or on the Red Bull app, and we cast it to our phone. So, I mean, I love that. The content's awesome, and I watch it with my little son. So we've been enjoying that. Usually once a night, we'll watch a little, 10-minute or 5-minute little biking video. So
cool.
I've been enjoying that a lot.
Yeah, they do some really cool music stuff too. I've definitely enjoyed some of the music content that they've been making. Speaking of which, what's some cool music you've been listening to?
Oh man, I'm always listening to new music. I'm a big fan of punk rock and heavy metal. So
nice. Like what?
Oh gosh, I got to think about some good recent examples of stuff here.
That sounds like Kilberg's wheelhouse.
Well, I don't know what you're talking about. Not a metalhead over here. I don't have 5 guitars sitting behind me.
It's funny with so I subscribe to Apple Music, and they just always have new stuff coming out. So I'm always kind of just like downloading stuff and listening to it, and I kind of just put stuff on shuffle. So I'm trying to think of albums that have come out this year that I think have been like really, really good.
Have you heard the latest Hum album, Inlet?
Yeah, I did hear that. It was good. It was I actually I downloaded that and I listened to that. Yeah, it was pretty good. I remember those guys from the 90s or something, and I downloaded it again, and I was like, that's cool.
Right,
Looking through what I got here. I've been liking this band called White Reaper. I don't know if you guys know those guys. They're not like punk rock. They're just like kind of good rock and roll music. And there's like these young kids, and they got some good stuff that I hadn't listened to them before. I like them.
Nice.
I don't know. There's a bunch of new metal stuff that's supposed to be coming out later in the year that I'm looking forward to. But as you guys know, a whole bunch of